Good morning, everyone. My name is Keenan Paget. I'm a dual CCIE route switch as well as data center, as well as certified in VCP6 NB, which is the NSX cert for VMware. Today with AGI, we're going to go through the motions of NSX, explain the benefits, why it's beneficial within the environment, how it assists in the SDDC design for data center, and how it helps in day 2 operational tasks. So please stay tuned and enjoy. So it's time to virtualize the whole data center. The whole idea between that is adopting a software-defined data center methodology. And what that does is optimize the environment for rapid development and delivery of all applications. A good virtual environment is agile, efficient, and secure, and the key component to that is network virtualization. So what exactly is software-defined data center, or SDDC? What it is the ability to decouple the software from the hardware. So what you're doing is actually using the intelligence of the software, its operational model for VMs, and allowing the automated provisioning of configurations within the software. So the intelligence lies there, and the hardware just becomes really pooled resources. Whether it's pooled compute, network, or just storage capacity, it's there. It's vendor independent, so you can definitely go for the best price and performance because it's just a staple or an underlay, and whatever assists in simplified configuration and management, because again, the bulk of the workload and intelligence is actually decoupled and residing in the software. There's actually 4 things, or 4 elements, if you will, within a typical data center today. You have your application, which the app guys love. You have your compute, your storage, and your networking. Now, we've seen advancements in applications, we've seen advancement in compute and storage, but there's one component that actually has been left out, and that's the network. With the lack of virtualizing the network, it holds you back really from doing things like keeping up the pace with the business. The business constantly grows, it scales, and we need to adapt that model as well. Securing your data centers. We all know that security is very, very high on the list to staying out of the newspaper, but it's a little bit difficult in doing so. And last but not least, controlling your cost. A lot of organizations feel that they can attack a problem by throwing money at it. That isn't necessarily the case. In my experience in building data centers, it only expands the problem. One of the things that NSX truly focuses on in its native feature is security, providing security. What NSX does is it actually puts a firewall on every VNIC, if you will. So before the server even communicates with anything on its subnet or its segment, it's already traversing a firewall. It inherently does that to provide that granular policy and that zero trust method, which we know and love. You definitely have some type of whitelist there, as opposed to permitting anything and denying what you need, what you don't want. You're pretty much denying everything and permitting only what you need. This assists in the microsegmentation and secure end user and DMZ everywhere, or anywhere rather. So if we look at the icons to the left, what we actually see is the VMs, but firewalls associated to every VNIC before it hits the segment. In between the two, we see some type of filter, and then going upstream, we have our other network components. But the thing to focus on here is that we have 3 particular tiers, 2 VMs in each tier, but a firewall for each VM. Very, very important. What we're doing is adopting the next generation networking model. So what NSX has done, or VMware rather, is actually put networking components on the hypervisor. And the hypervisor resides on an host. So each particular host can have routing, switching, load balancing, and firewall locally to the firewall, to the host, excuse me. With that being said, if it's on every host, then it's clearly shown as a distributed model, and that's where we benefit. We have distributed networking resources, day-to-day resources that we use on a regular basis, the routing, the switching, the load balancing, and the firewall. Now within the hypervisor, and on every hypervisor, on every host, the distributed model breeds agility and flexibility within your environment. It truly is the next-gen model. So here we see that we have the route, switch, load balancing, firewall on every host in a distributed fashion. With traditional data centers, without SDDC, we have this old way of doing business. It's more manual. It's definitely slower in rolling things out, but it's more expensive. It kind of breaks up the uniformity. Different organizations, different buildings within the same organization kind of use different hardware. There's no standard uniformity. They take a different approach. Certain policies are here but not there. And it's time consuming, which ultimately leads to expenses. So what we have is these organizations having silos within the organization as opposed to being more standardized, being more uniformed, knowing that the same policy, but different, can be in multiple locations. So it's very, very key in bringing uniformity to an organization that typically doesn't have it. And the whole silo approach just doesn't work anymore, right? The way we do business in this one building should be the same way we do business in all the buildings within this organization. We shouldn't do things separately. Silos can lead to misunderstandings. So the solution is NSX. What we do is we bring everything together, the compute, the network, and the storage and security, and we actually control it within the virtual space, bringing uniformity throughout the organization. And what this also does is reduce the hardware complexity. For all of our OpEx guys, you all know when it's time to bring up a new server or add a server, we can easily be concerned with the optics, whether it's fiber channel or Ethernet, 1 gig, 10 gig. There's multiple things to work about. We kind of reduce the operational expenses because the networking gear is virtual in the same space where the servers reside. So we're no longer racking and stacking, working with the data center to get the cabling and these mass runs from one rack to another. All of that pretty much goes out the window because we have the networking components within the virtualization space. It improves resiliency and availability because the actual components move at the speeds needed within each host. You got to remember, from a firewall perspective within NSX, we can pump 20 gigs out of each host. So if you have 2 hosts, that's capable of 40 gigs of throughput. So they're not skimping there on processing. But at the end of the day, we have to plan for the worst, even though things are running the best. NSX also expedites recovery and decreases downtime. And at the end of the day, we need those 3 things in order to have the environment running as efficient as possible in order to enable business continuity and application continuity. Now, is the world ready for the new model? Absolutely. I have yet to see an organization adopt this new model and not grow accordingly. I mean, it inherently provides the secure infrastructure one needs to stay out of the newspaper, essentially. There's breaches all over the place. This will definitely help prevent that zero trust environment. It's dynamic to the business's environment, meaning, again, the underlay of the physical construct is really just the physical construct in a pool of resources. In our previous slide, we saw that all the intelligence is really in the software, which resides on top of this infrastructure. So it's definitely dynamic to the business, but it increases application visibility and mobility by allowing the firewalls and securities to move with the VMs. When you vMotion a VM within NSX, the firewall rules go with it as well. So we're staying on top of policy and posture throughout the environment. So network virtualization will inherently give you 3 things: security, which we've kind of covered in great detail, but automation. If we have certain processes that we do on a regular basis, we can always rinse and repeat and provide that same process. Remove human error and help turnaround times get reduced. But at the end of the day, application continuity is what we're going for, right? The application is what is the brunt of the business, the brains of the business, and keeps everybody employed. We want to protect that application and keep that application up and running at all times. Now, for my VMware guys who are familiar with some of the other products, if you're familiar with vRealize, automation and orchestration, and the whole idea of blueprints, for some organizations, instead of doing the tedious and mundane spin up a VM, spin up this many VMs for the developers, this many VMs for the application guys, we develop blueprints. And blueprints are essentially saying these pools of resources are configured this way, so when you need it, boom, you hit that blueprint, you spawn off your particular instance, and you have some pre-configured devices. Well, the beautiful thing about that is that since vSphere or VMware is the predominant hypervisor within the market today, it makes complete sense to also incorporate NSX into a beautiful suite and tool that's already in place for automation. So now we can automate the creation of the VMs, but then now we can automate the creation of the logical switch. We can also automate the creation of the distributed router. We can also automate the creation of the firewall. So in an environment where we have multi-tenancy, we could essentially go to the catalog and hit a button, spin up a certain designated amount of VMs, but then also spin up the network to support those VMs. You see where we're going? We're changing the complete game as far as how fast we can get to a go state. And if we do our due diligence to make sure that these components are fine-tuned, a tenant is within a click of a button. From a more shared resources and not multi-tenancy, the development of a new segment or a new leg can be at the click of a button. And it just makes for a better environment. Now, with that being said, another feature that NSX can do is something called vCross. What it basically is developing two NSX instances in two different data centers, but then allowing them to communicate as one. So you can have an instance where in data center 1, if you had a failover, SRM kicks in, boom, it moves it over to data center 2. Previously, we had to make some changes. Now, the firewall rules stay with the VM as it goes to the new data center, and it automatically incorporates or adopts the networking in that particular data center as well. So when we move VMs over to a new data center, they're functioning seamlessly. And that's exactly what we're looking for. The more seamless the environment can adapt to anything, the more resilient it can be in ensuring application continuity. I mean, from a disaster recovery perspective, or multi-DC pooling, or even a cloud perspective, this is phenomenal. We get to move workloads in between data centers and ensure that the policies and everything are where it needs to be, so that we constantly support the environment. And at the end of the day, that's all we want to do. So ideally, if we have the server compute virtualization, and then we now adopted the network virtualization, we have complete automation. We literally have complete automation. Now let's talk a little bit more about the next generation networking model. Now this particular model, again, allows the resources that we once saw as individual rack devices, and if you're lucky, each one of these is one U, but we get all that back. We get that rack space back. So we get our load balancing, we get our routing, we get our switching and firewalling within the hypervisor. Nothing moves. And with that being said, I just wanted to bring up a little bit of an example. So for anybody who's been out in the field for a decent amount of time, this is a pretty standard environment. We have our layer 3 constructs, which is our Nexus devices. Definitely want to go with Cisco, a tested field-proof type of networking components. Phenomenal. And then we have our UCS, which is also a typical construct in reference architectures. Now, if we look at the left, what we're doing is basically explaining the workflow or packet walk to the firewall. Now, this example is within the same host. So we have two VMs, two different subnets on the same host. Now, to the left, we see that it has 6 hops going from the VM to the UCS blade to the fabric interconnect to the Nexus 7K, hitting the firewall for its resources, then it comes back down. In the same example using NSX, the firewall is on the VNIC. So the VM literally talks to the firewall directly connected to it, says, okay, well, we know exactly what's going on, and we also know how to reach this particular destination, and it goes right across. We have 0 hops for firewall resources. Same host, but we have 0 hops. Phenomenal. Now let's go to the right. What this is 2 different hosts, different subnets, different hosts. We see the same trombone effect. The VM traffic goes to the UCS blade, Fabric Interconnect A, Nexus A, if you will. I'm sure they're definitely running a VPC. Then it goes to the firewall and comes back down. Now, this is two different hosts, but look at NSX. With NSX, it hits the VM, hits the blade, it hits the Fabric Interconnect, and then it goes right back down to the blade. Now, I just want to take a second to highlight something here. In each example, the second and the fourth, when using NSX, we do something that's very, very critical that may be unseen that I'd like to highlight here. We save utilization. In examples 1 and 3, we saturate the link going to Fabric Interconnect A, we saturate the link going from Fabric Interconnect A to Nexus A, and then we saturate the link, tromboning traffic as well, going to the firewall, which is probably not an aggregated link or LACP, and it's using one link. Now we're sending duplicate traffic, hairpinning, and tromboning over that link. But if we look at examples 2 and 4, the utilization is not being hit as hard on the Fabric Interconnect to the blade or from the Fabric Interconnect to Nexus. So we may not need that high-powered Nexus device. We may be able to bring it down a little bit because a lot of the traditional networking resources and utilization is actually taking place on the blade. So that utilization savings alone assists the operational guys. Here we have the same effect, but this time we're not going to the firewall. We're just using traditional layer 3 resources. And this is a wonderful example because in today's environment, this is typically how it's designed. You have your ESXi or your vSphere environment, but then all the default gateways are actually on some type of layer 3 capable device outside of the virtual environment. So what we have here is just to do routing. In example 1, all the way on the left, we go all the way to the 7K and come back down. But in the second example, we're doing routing locally on the blade. 2 different subnets, 0 hops. We saved utilization as well. To the right, host to host. Same thing. We have the tromboning effect, adding extra utilization, even to a 10 gig link from the Fabric Interconnect A to the 7K. We can have a 10 gig link. It's still taking up traffic, folks, and we're still talking about just traffic between 1 VM. Oftentimes we have 100 VMs. In our last example, we see here traffic hits the Fabric Interconnect A and it comes right back down, and that's different hosts, different subnet, different tier, 2 hops. So we're definitely saving. And we're saving time, we're saving money, and we're saving utilization. Excuse me. Now, the traditional operational method is just not feasible. I mean, we had to create several firewall rules before provisioning, update the firewall rules during or right after. People rarely do their proper cleanup and delete firewall rules when applications are decommissioned. And then we still have problems between east-west traffic. Now, the idea of a perimeter firewall is still needed, but not needed as much. So ideally, this is what we're trying to go to, an all-software construct. So we have our layer 2 switching, we have our layer 3 subnets and routing, even NAT. But if we look at it, the physical layer underneath is just the physical layer. We still have our 3-tiered structure. And with virtualization taking on greater tasks, we can now virtualize database tiers to have everything within the virtualization space. It's pretty clean. Now the traditional vSwitch, of course, we all know, goes from 1 VM and then hits that vSwitch on the hypervisor and comes back out. That's fine. That works well. There's a lot of environments today where it still utilizes that. But then when we're looking at traditional layer 3 routing, what are we doing? We're leaving the VM, we're leaving the ESXi host, we're going out to the physical world to come back down. We still have this tromboning effect, and it's not working these days. And when we incorporate a virtual environment, things flow a little bit better. It goes directly to the virtual resources, and it comes back out and talks to the VM as expected. And this is exactly what we need to continue to move forward, distributed network services. This deployment is non-disruptive because we're not touching the traditional things that we once touched to get things running. And as you can see now, 1 VM talks to the network resources, distributed services, and then it goes across to the ESXi host, and it talks to the VM accordingly. Everything is being fully utilized and utilized accordingly. And at the end of the day, we achieve network isolation natively. Natively. If you look at this visual, we have two 192.168.2.10s, and we have two 192.168.2.11s. But they're completely different isolated environments. No extra work needs to be done because it inherently and natively has that isolation built in. I'll give you a great example, another one for the operational guys. If you had to develop a new subnet, new VMs, what would you do? Well, I'll tell you. Typically, you would open up a change control ticket. You would have to work on the firewall. You would have to work on the core device, whether it be the router or so, and the core switching. And if you did your hierarchical structure, you would touch your core, you would touch your distribution, and you probably would leave out the access layer, but you would definitely have to touch those two layers. Change control can be up to 3 weeks to make a change in those devices. You're going to hear questions like, will this interrupt anything else? How can you guarantee that? Let me see your configuration script. We alleviate that with NSX. Reason being is because when we allow routing, we're allowing routing for that one instance. When we bring up a new subnet, we put the default gateway on the DLR or the network and virtualize the router, and that's the only thing we've touched. So change control drastically gets reduced. One more point on security. Again, I said for the security guys out there, the perimeter firewalling or the perimeter method is still very, very good. We need perimeter firewalls. It's just insufficient to the point where we develop the jelly bean effect. And the jelly bean effect is a hard outside but soft and gooey in the middle. I'll give you a clear example. This particular virus was able to get in, and now it can go wherever it wants. There's nothing stopping the lateral movement from east to west. Okay, now he's ready. He's pointing at his other virus. Let's see what he does within the SDDC NSX environment. He can go nowhere. There's a firewall on every VNIC, meaning he's constantly going to be scrutinized and contained wherever he goes. And I've even seen organizations implement rules that stop file sharing. So we definitely minimize the impact of something intruding and trying to take over. So the biggest difference, I mean, it's pretty easily seen. I mean, we have our physical firewalls, which is still needed. It has some type of cap, and that could be the choke point, whether it's 100 gig throughput or what have you, but it's still a physical firewall. You know, it has physical capabilities. We still need perimeter firewalls, but we need a little bit more. Virtual firewalls, very, very good. A lot of them are limited to 1 gig, but they're still very, very good in helping resolve some of the interior concerns or vulnerabilities within your virtualization space. But still, it's still one particular firewall that's virtual that traffic is pointed to it. On the right, we have the distributed firewall. It's everywhere. It's on every host. It distributes cleanly. It supports up to 20 gigs per host. It's definitely vSphere kernel based, so the performance is definitely there. It's a distributed enforcement, but it can be automated for policy management and operations. So it has the benefit of day 0, 1, and 2 baked in. And again, I have to stress the fact that not only does this thing support 20 gigs worth of throughput, but it's zero trust and hypervisor based. So it's ideal for microsegmentation. And let's not worry about the performance. In this particular chart, we see no filter is close to about 20 gigabits per second. But then when we add a filter, we're about 19. So minute hit, but still doing filtering. We're at 19.7 with filtering. So it's I don't want to necessarily say hitless. It does take a little bit of a hit, but it's minute. And the benefit that you get from having a firewall on every host to every VNIC is immeasurable. So again, let's talk about some of the constructs that you would have. You would have the isolation method where application A can no longer talk to application B, or it never could talk. We don't want communication. We have the explicit allow, which is the 2-tier, 3-tier construct. So the application is specifically allowed to talk to the database tier on these particular ports, nothing more, nothing less. Then we have the secure communication. This involves guest introspect and service insertion to say, hey, let's do deep packet inspection in between these 2 tiers to make sure everything is where it needs to be. NSX is doing a great job of developing this ecosystem. One thing I see that's pretty much deployed 7 out of 10 times would be the Palo Alto. Palo Alto's relationship with NSX is just phenomenal. And what it can do from a layer 4 to a layer 7 for deep packet inspection is nothing shorter than great. I do have to say that. So the advanced services insertion, again, from a Palo Alto perspective, you have your Panorama, which you would manage. It's a centralized management system. And Palo Alto has been slick enough to actually put VMs, firewall VMs, on every host, sharing that distributed model. So now, when we need deep packet inspection between tiers, we're not searching for the firewall. The firewall is on the host, on every host. So deep packet inspection happens locally as it's going through its applications. And now we're firewalling through deep IPS-IDS investigations and deep packet inspection. As you can see, now we're traffic steering to these particular firewalls on the host and then running our traffic that way. Very, very phenomenal. Now, when you're developing your groups, of course, grouping is an ideal method, but when you're developing your groups, it's no longer based on the subnet. I mean, I guess subnets inherently group themselves because they're in one subnet. But if you want to develop a policy and you don't want to do the typical 5-tuple, source destination port, things to that effect, we can also group it in different methods like operating system. I've seen some methods where they group it based on the host name of the machine. So if you type anything web, it automatically falls into that web group, and it only allows HTTP and HTTPS and blocks everything else, allows application ports. So very, very secure and dynamic that way. We can group it on services or tier or regulatory requirements. Last but not least, we can group it on posture. If it meets the corporate compliance and it has this type of attributes, please push it into this group. So we have phenomenal grouping and capabilities. But at the end of the day, what we're taking away from this SDDC approach is several things. From an automation standpoint, we reduce infrastructure and provisioning from weeks to minutes. So we can spin up a developer cloud, we can spin up multi-tenancy with ease. From an application continuity, we spoke about vCross, routing and switching in 2 different data centers, but the ability to route and switch and make it look like one data center. We kind of developed this hybrid cloud of networking or metro pooling, where every data center can provide some type of resource that we can all use, and this reduces the RTO by 80%. Last but not least, security. Let's do what we can do to avoid breaches and stay out of the newspaper. With that being said, we have microsegmentation, we have DMZ anywhere, and we completely secure the end user. Now, I wanted to save this slide for last because I wanted you to see the components that allows us to do all of the great things I spoke about prior. Now, I will mention that NSX is a one-on-one correlation to vCenter. So as you can see here, we have one vCenter instance to the left. We have one NSX manager. It's a one-on-one correlation. It's a one-on-one correlation. After that, we have, so going to the right from the vCenter, we have the one-on-one correlation to the NSX manager. Going downstream, the NSX manager has controllers. Now, these controllers help keep track of VXLAN, transport zones, as well as VXLAN segments. So the controllers is definitely the brains of the operation, and for redundancy methods, VMware recommends deploying 3. So we have the vCenter that communicates to the NSX manager. The NSX manager communicates to the controller, which in turn communicates to the NSX edge devices, as well as the vSphere compute devices within each host. And this is pretty much how we make our communication. So the NSX talks down to the controllers, which basically talks down to the firewalls, the routers, the load balancers, and the switching within each cluster. And overall, we get that nice, clean feel of communication and packet flow. So everything works as expected. Now, one thing I did want to cover a little bit is vRealize Network Insight, or VRNI. And what that is basically it's a server, a VM, but it's a monitoring analytics box. And what it does is it integrates into your vSphere or vCenter, but then it gives you that visibility and intelligence that one didn't have prior to. It's definitely a great tool to have because it gives you that insight into your vSphere environment. But then with this insight, it also allows you to cater great micro-segmentation policies and just help you launch into NSX from a deployment perspective. One of the things that helps you does is get that analytics and understanding for your east to west traffic and use that to help design micro-segmentation. It gives you the 360 overlay visibility, so you get to see from the physical environment to the virtual environment and the actual packet walk there. It also helps when understanding your VXLAN LAN communication mappings. And just to give you a quick note on that, there are several designs out there that support the VM to physical communication. Specifically, NSX uses something called an L2 bridge, and it can be used for migration from P to V. So let's say you have some databases that are physical, and you have some applications and web servers that are virtual. You can actually develop a layer 2 bridge so those particular virtual servers can talk to that physical box until you get an opportunity to virtualize that physical box. Or you may just leave it physical and allow that communication to take place. But this is what you see from Network Insight, or AKA Verni. Beautiful tool. How it works is basically the UI, or the user interface, talks to something called a Network Insight platform. Now this particular platform can be built to certain specifics. We have there a medium is 8 vCPUs, but this particular VM downstream talks to the collector. Now the collector is the one that actually reaches out to ESXi, vCenter, NSX Manager, the edges and the controllers, and it reports back that data. Read only, it's not going to change anything, but it reports back that data after it collects it to the platform box, which then in turn talks to you using your Chrome or your Firefox at your workstation. So it's definitely separated so that the workhorse is definitely the proxy box. The platform puts it together in a nice, pretty format for you. And then you control your policies and reports based on your access there. So it's definitely a clean and smooth tool. It gives you that insight. You definitely need to understand what's going on in your virtual environment today, but then it assists in massaging your environment to what you need it to be tomorrow. Again, some of the use cases is planning for microsegmentation and ensuring compliance. Another one is performance optimization to make sure that the overlay and underlay are performing as expected. But last but not least, it assists in best practices. You want to make sure that things are clean, especially if you get the call that we have auditors coming tomorrow. Everything wants to look as clean as possible. Here are some of the requirements when developing this. I personally recommend ESXi to be at a 6.5 level. 5.5 is pretty much falling off of the map. We definitely want virtual distributed switches. I mean, it's required for NSX, but we should be using that today because that's definitely a key in providing that flexibility and scalability. So these are some of the requirements, not all, but just some. At the end of the day, we have two different sizes, the medium and the large. Medium being 8 cores, 32 gigs of RAM, large being 12 cores, 60 gigs of RAM. But at the end of the day, you need to make sure that the proxy box, which is more important, is big enough to support the environment that it's proxying and to make sure that it can give you the output you need. One more requirement, just to let you know. These are the protocols and ports that are needed for Verni to actually do what it needs to do and query in your environment so that it can give you those reports. Very, very important that we allow those ports. Critical ports are 5. This is a brief snippet of what you would see. And let's dive into this particular snippet. So let's look at it. What we have is east-west traffic is at 94%. And this basically is saying VMs to the left will communicate with VMs to the right and vice versa. Layer 2 switched, we have about 37%. That's a pretty good number, but it doesn't really help us. It lets us know that we have a lot of packets being switched, but it doesn't really help us. Routed. We see 62% of the traffic is being routed, meaning this is subnet to subnet communication. These devices are not on the same subnet, so it requires some type of layer 3 construct. Going down, routed within host, pretty simple, 6%, not too bad. VM to VM, 85%. So now we know that we need to we need a lot of routing, 62% of routing. 94% of that routing is for traffic that's east to west, and 85% of that east to west is VM to VM. Sounds pretty clear, like this is an ideal situation for NSX. We have a lot of east to west traffic that's VM to VM and requires routing. We put a distributed router on each host. We use that routing capability because it's VM to VM and never leaves the ESXi environment or the vSphere environment. We continue to function as expected, now taking care of everything within the virtualization space. If I seen this output when running Vernie in your environment, I would definitely recommend NSX. The charting, it's a nice little graph there to let us know this particular VM is talking to this particular device, or this VLAN is talking to this VLAN, which is a group of devices talking to a group of devices. So now we get a better understanding of the application flow. It helps us in developing microsegmentation policies, but without even doing that, we can just understand the application mappings. We know that this VLAN needs to talk to this VLAN in a bidirectional sense. In this example, VLAN 1021 is talking to VLAN 256 bidirectionally. It would take a good period of time, a couple of clicks, and a good amount of searching to understand that, but Vernie provided that to us in one quick chart. So the benefits are definitely there. And it can be used to support arguments or develop policies, specifically automation security group policies. That works well with this type of data. Microsegment zero trust policies. That works well with this data. Or just a virtual network and design can be assisted using this information. I mean, at the end of the day, we would like to provide security tags, but we need to know what's traffic or what traffic talks to what traffic and the purpose of that traffic to develop a clean tagging method. This is what I think is beautiful. It's a connectivity graph. So if Vernie is integrated properly, we can go through this walk and see exactly what it's doing. So initially, we see a VM that's sitting on top of a pair of firewalls. These are the zero trust VNIC firewalls from the distributed firewall. We see it goes down through the policy, and each tan box is actually an ESXi host. So we see it go through the firewall down to the first construct outside of the ESXi host. We actually see the traffic leave the host, and it's hitting a physical Pan Am device. So that is Panorama or Palo Alto's firewall. Then it goes through a couple of network devices. It also tells us that it goes through a physical switch. So if your NSX or if your Cisco Nexus devices are integrated, it will actually say Nexus 7K or 9K. We see it go through several physical devices, and then it goes back into the second ESXi host, hits a couple of more resources, then goes to the right and goes to the third ESXi host. Then it goes to that destination VM's firewalls, ultimately hitting that destination VM. This packet walk would take quite some time to develop if we didn't have this tool. Using Vernie, we saw that there's a firewall policy directly beneath the VM. It left the ESXi host into a physical firewall, traversed its several physical devices, went back into the ESXi host, and continued its communication. And again, the monitoring and best practice checks are there, so we'll definitely be good to go in understanding what exactly is going on. And at the end of the day, understanding is key in developing your software-defined data center. Inherent microsegmentation, optimization and visibility, and ensure best practice. Thank you. My name is Keenan Padgett, and this webinar has been produced by Adam Gross, Inc.